we're going to finish up chapter 3 and start chapter 4 today. And there are 3 sheets back there that everybody's supposed to get. That's for chapter 4. What is an absolute value? This is from what you've learned in high school. What's that? Okay, that's one property of it. Yes. What does it look like? It's just, yeah, the absolute values looks like this. It's a value. So if I gave you that, what would you have to do first? You have to simplify it because it has to become a value. What is a value? A value is one number. It's one number. So I would have to first do inside there. So the absolute value of 5 is 5. Likewise, the absolute value of negative 5 is what? It's 5. So basically, an absolute value is the distance from any number to 0. The reason we say distance is because distance can never be negative. Distance is simply an absolute value term. For example, if you're in Grand Prairie and Dallas is over here and Fort Worth is over here, let's say they're both 10 miles away from Grand Prairie. So is this one negative 10 miles? This was positive 10 miles? Or are they both 10 miles away? They're both 10 miles away. So they're both the absolute value. They're both 10 miles away. So that's why we use this concept. But you have to be careful. What would that answer be? Why negative 3? Right, because it's outside. Order of operations. Order of operations says do what first? Special operations. Can you do anything inside there? No. So we have to get rid of it. What is the absolute value of 3? 3. And the negative stays there. How about the negative of absolute value of negative 2? What's that going to be? No. Think of order of operations. It's going to stay negative 2. Because first thing you have to do, can you do anything inside the absolute values? Can you do anything inside there? No. It's just a number. So what is the absolute value of negative 2? 2. And the negative stays out there. So the answer is negative 2. You cannot distribute inside there. If you had to define it with an equation, that's the equation. And think about it. We had negative 2, absolute value of negative 2. So this is my x. In place of this equation, that's x. So I put that inside there. What is negative 2 squared? negative 2 times negative 2 is negative times negative is positive. 2 times 2 is 4. So the squared gets rid of the negative. It makes everything positive, but it inflates it. It doubles it, which is why we square root it. What's the square root of 4? 2. So that's how we just go. Instead of doing all that stuff, we simply say that. And you could be thinking, well, I thought you said it's the distance away. It's the distance. Here's 0. Here's negative 2. Remember what the distance formula was? X2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. But in our example, x1 is always what we start off with. It's 0. So this is x2. There is no y values. So we get negative 2 minus 0 squared plus 0 squared. There's no y value. It's the distance formula start off with the Pythagorean theorem. It's defined as by the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared. What it does, it tells us the distance between these 2 points. So no, it doesn't have to be. The formula itself is d squared equals that. So we have negative 2 minus 0 is negative 2 squared. Negative 2 squared becomes positive 4. Square root both sides. D equals plus or minus 2, but you cannot have a negative distance, so D is equal to 2. That's how it works. But so you don't have to do it all the time. We just do the shortcut. It is still the distance. All right. Because of that, because if I said the absolute value of negative 2 is 2, or if I said the absolute value of any number is 2, what are my possible answers? What's the formula for absolute value? What's the degree? 2. We have to have 2 answers. So if I say the absolute value of x is 2, here's 0. So it can go this way 2 spaces, or it can go this way 2 spaces. Those are my 2 answers. So x is equal to positive and negative 2. Or in general, anything, any number I put in there, when I drop the absolute value signs, I put a plus or minus in front of the answer. That gives me my 2 answers. That makes sense? So, like for example, 1. If I said my absolute value equals 5, what does x equal? Positive, negative 5. Because all I'm saying is give me a number that's 5 units away from 0. It could be either of those. That's 5 units, and that's 5 units. The same logic with larger equations. I'm going to build up to this example. Solve for x. It's the same as the square root. Remember the last section we dealt with radicals? How do we solve for radicals? What's the first step? Look at your notes. This is why it helps to review your notes at nighttime or before class. What's that? What radical? What's the first step of solving it? No, that's irrational. What's that? Before that, the first thing you have to do is isolate it. Before you get rid of the square root, you have to isolate it, get it by itself. Same as solving for x. What do you have to do? You have to get the x by itself and then solve for it. So is the absolute value, same thing here. First one is isolate the absolute value. In other words, there cannot be anything outside of it, anything multiplied to it, divided by it, or added and subtracted to it. Is it isolated? Is it by itself on one side? Yes, it is. There's nothing else around this. It is by itself on one side. It is isolated. That's what isolated means. There is no absolute value plus or minus anything. That's isolated. Check. We got that done. 2, drop the absolute value. When you drop the absolute value, what happens? You get the plus or minus of the answer. We just talked about that. When you drop the absolute value, what do? You get the plus or minus of the answer. So when you drop the absolute value, then you put a plus or minus in front of the answer. Then you solve for x. Which means I do what? I'm solving for x. Subtract 2. Yeah. It's not a trick question, ladies and gentlemen. It's just straightforward. So we get -2 plus or minus 4. Now we solve both of these. We have x equals -2 plus 4, x equals -2 minus 4. This gives us our two answers. And since we're in this part of the course, always check your answers. So we have absolute value. The equation is x plus 2 is equal to 4. So my x is 2, 2 plus 2. So the absolute value of 4 is 4, and that equals. So that works. I do the same thing with -6. -6 plus 2. -6 plus 2 is -4. The absolute value of -4 is 4, so it works. What's my first step in this example? What's my first step? Okay, yeah, you just read that. What is it? What does it mean? What do I do? How do I do that? What do I do? Divide by 3, because 3 is multiplied to this. So I divide by 3. 3's cancel. Now I have the absolute value isolated. 6 divided by 3 is 2. Is it isolated? Yes. There's nothing in front of it, behind it, above it, or below it. So what do I do now? I drop the absolute values. When I drop the absolute values, what do I do to the other side? I put a plus or minus. Now I just have a regular equation, and I solve it like we normally do. I do one side positive and one side negative 2. So I add 1. 2x equals 3. 2x equals negative 1. Solve for x, I divide by 2. X is equal to 3 over 2. And x is equal to negative 1/2. Always check your answers. So in place of x, I put 3 over 2. In the first one. And the second one, I put negative 1/2 in place of x. So what's my first step now? How to solve this? What's that? We're going to do the same thing. Nope. We're now checking the answers. We're not solving. There's no x to solve for. Nope. Order of operations. You do the inside the absolute value first. What can we do inside the absolute value? What can we do inside there? Well, repeat the process. Are there any special operations inside there? No. Are there any multiplication divisions? Yes. You do that. I mean, yeah, that's multiplication. Here's division. So yes, there's multiplication division. So I cancel the 2's first. That's division. So the 2's are gone. Repeat the process. Absolute values. Can I do inside there? Yes. What is 3 minus 1? 2. What's the absolute value of 2? 2. 3 times 2 is 6. So it works. Repeat the process on the other side. You have absolute values. That's a special operation. Can we do anything inside there? Is there any multiplication division? Yes, there is. 2 times negative 1/2. That's multiplication. I got to do that first. The 2's cancel. So I get negative 1 minus 1. Those 2's are all gone. Inside the absolute values, negative 1 minus 1 is negative 2. Since they're both negative, I add the numbers. The absolute value of negative 2 is positive 2. 3 times 2 is 6. 6 equals 6, and that works. The process, the steps never change. Order of operations from day one, you have to use it till forever. How about this one? Go ahead and work this one out. First step. Because yes, you're supposed to identify. Yeah, we know that. But what's the first step? No. Take away 5. Always get rid of the plus and minuses first. So we subtract 5 from both sides. One minus 5 is negative 4. Next step. Very good. Divide both sides by 2. Negative 2. Next step. No. Can an absolute value ever equal something like negative? No. So you're done. Once you get to this point, you can't go any further. There is no solution. Because had you checked your answers, you would have known that's not the right answer. Because anything plus 5 is not going to equal 1. This can't be negative, so there's no solution. That's why the CYA is super important. Because absolute value of x can never equal a negative number. It just simply goes by the definition of absolute values. It can never equal a negative number. All right, so let's build a bigger one here. Let's do the example 2, which we're going to start off with. X minus 3 minus 1 equals 4. Because it's an absolute value, we know we have to have 2 solutions. So first step, get rid of the 1. Add 1 to both sides. Drop the absolute, since it's by itself, we can drop the absolute values. When you drop the absolute values, you have to put a plus or minus in front of the answer. So now we set x minus 3 equals positive 5. X minus 3 equals negative 5. That's where the plus or minus come in. This side is the plus, this side is the minus. Or it doesn't matter, you can put them on either side you want to. Add 3. X equals 8. X equals -2. The equation is x minus 3, absolute value, minus 1 equals 4. So when x equals 8, we have 8 minus 3 minus 1 equals 4. 8 minus 3 is 5. Absolute value of 5 is 5. 5 minus 1 is 4. So that works. Now we'll look at x equals -2. -2 minus 3 minus 1 equals 4. -2 minus 3 is -5. Absolute value of -5 is 5. 5 minus 1 is 4. So that works. So my answers are 8 and -2. The only time an absolute value can have only one answer is when? The only time an absolute value can have one answer only is when it equals 0. Because remember, absolute value is what? What does absolute value represent? The distance from where? From 0. So any other number other than 0, it's got a distance. So it has to have a positive and negative distance. So the only one that doesn't have any distance is at 0. All right. So let's move on now to inequalities with absolute values. Inequalities with absolute values. When we deal with inequalities, we deal with sets of numbers, not just one number, not a positive and negative one number. It's a whole set of numbers. So we have two possibilities here. We have two possibilities. The absolute value of x could be less than some number, or the absolute value of x is greater than some number. Remember, it's how far a is from 0. Here is a is here, and there's 0. What does this statement tell me? I start at a. Am I going towards 0 or away from 0? Towards it, because I'm going a. It's x is less than a. So if it's less than a, it's got to be greater than 0. Since it's absolute values, we also have to have a negative a. If it's less than positive a, then it has to be greater than negative a. Because both of these sides here represent my value of x. So if I have absolute value of x is less than a, what it turns out to be is this equation. Because it's going from 0 to a. That means it has to go from 0 to negative a. also. You have to think of the negative side as well. If here's my value A and there's 0, if X is greater than A, which direction is it going? Yeah, it's getting bigger, so it's going away from 0. It's going all the way to positive infinity. Well, we also have to look at the negative A aspect. It's got to do the same thing. It's got to go away from 0, so it's got to go to negative infinity. An easy way to remember it is if this is 0, I have to be able to fold it at 0 and get the same picture. They have to be mirror images of each other. So if I took this and folded it, I get the same answer. If I took this one and folded it, I get the same answer. So if it's greater than, if X, absolute value of X is greater than A, it's going away from A. It's getting bigger. That means it's going to infinity, which means the other side is getting smaller. So this one is written as two ways. It could be X is less than negative A, or X is greater than positive A. There's the reason there's an or there is because it's not on the same side. If I pick a number here, it's going to be between negative A and A. If I pick a number, that's no problem there. But if I pick this one, I could pick it from over here, or I could pick it from over here. That's why the or's there. And then, or if you want to use the set notation or interval notation, we'd have negative A to A, or negative infinity to negative A, unioned with A to positive infinity. We've talked about that, so I'm not going to rehash that. So what would that one look like? What's that? Are you sure? Because it says X is less than 3, so it can't go to the right. Again, always start off drawing a picture first. There's your 0. There's 3. It's an open circle, but there's no equal sign there. What does this tell me? Forget the absolute values right now. What does it tell me? Was that? Well, yeah. Because X is less than 3. It means it's going to the left. It's pointing to the left. So I have to go this way to 0. So from the negative 3, I do the opposite. If I'm less than 3, I got to do the opposite. I'm greater than negative 3. Think of this one. If I'm greater than A, then I have to be less than negative A. The positive and negatives are simply they're opposites of each other. So if this is less than A, then this has got to be greater than negative A. It's got to be the opposite statement. So how would I put this in set notation? Negative 3x3. Yeah, all depends because you have to be able to do all three methods. It makes it easier to understand, and in case it asks for a specific one. How about that one? To the right. Okay. Do I put it open or closed circle at one? It's closed because there's an equal sign. And it goes to which direction? To the right. Very good. It goes to infinity. What's the other side going to do? That negative one, and it goes to the left. It's just the opposite. If it's greater than, it's going to be less than. If it's less than, it's going to be greater than. How about this one? Uh, Instead of 4, just make it 5. Just make it easier. No fractions. We can't do the graph just yet because we can only do the graph when we have the x by itself. So how do we set this up? What's that? How do we? But we have to set it up, solve it. We have to get rid of the absolute value. So what's it going to look like when we drop the absolute value? What's that? Nope. Isn't we could if it was equal to, but this is an inequality. We have to go back up here and look at which one of these matches with one of these. So what is ours saying? Is it greater than or less than? Less than. So is it this one A or is it B? It's A. So whatever is over here, whatever's by itself here, goes here and here. So this 5 becomes a negative 5 and a positive 5. Whatever's in the absolute value goes inside there. It's no different than if I just gave you that. You would set it up negative 5. Why did you put an X here? Because that's what's inside the absolute value. In this absolute value, it's X plus 3. Setting it up is half the battle. If you set it up wrong, your answer is going to be wrong. You notice how this is the same thing as this, minus the absolute values. So this has to be true. The other half now has to be true as well. What would I do next to solve it? Subtract 3 from everybody. Whatever you do, because you're solving for the middle. We did this before in chapter 1. We did this in 1.6. We did inequalities in chapter 1. It's just now instead of equal signs, we have inequalities. So we have negative 5 minus 3 is negative 8. 2x. 5 minus 3 is 2. Now what do we do? What's that? Divide by 2. Yeah, because we're solving for x. Only thing we have to look at is the middle term. All we have to do is look at the middle term. That tells us what we have to do. So negative 8 divided by 2 is negative 4. The 2's cancel, so it's x. 2 divided by 2 is 1. Now we can graph it. Negative 4, solid dot. Positive 1, solid dot. And that's everything there. Remember, these are your two formulas for inequalities. So what you have to do, here's the absolute values. So that's the absolute value of x. This is the number. So that's the a value. All you have to do is match this to one of these two, and the rest is done. So does this look like A or B? Looks like A. So all I have to do is rewrite it this way. What's my A? A is 5. So I have negative 5 is less than, this is my x, is less than A, or which is 5. That's all you have to do. Now solve for it. First step, now all you have to do is look at this middle term here. That tells you what you have to do. You're solving for x. What's my first step? Minus 2 from all 3 sides. Remember, this is called a tripartite. It means it has 3 parts that we have to work with. Negative 7 less than 3x is less than 3. Next step. How do we get x by itself? Divide by 3. So we have negative 7 over 3 is less than x is less than 1. And there's my answer. All you have to do is match the basic structure of this to either A or B. So what structure is it? A or B? It's B because it's X is greater than. This is greater than. This is your absolute value of X. This is your A. What it tells me to do is X is less than negative A or X is greater than A. This is my X. So I have 5 minus 2X is less than or equal to negative 1. So I have the negative side. Or 5 minus 2X is greater than or equal to positive 1. Whatever sign is here has to go in these two places. We're solving for X. So my next step is what? My next step is what? My next step is what? You guys are just saying a bunch of words now. What do you have to get rid of? Give me a number. Don't give me an operation, because you're just guessing operations now. There's only 4 of them. Yeah, you have to get rid of the 5 first. This is not part of X. So it's a positive 5, so we subtract 5 from both sides of both equations. Don't guess. Think logically of what has to be done. Mathematics is pure logic. You can't get to X until you get rid of everything else around it. So we have negative 2X is less than negative 6, or negative 2X is greater than equal to negative 4. From chapter 1, what do we do next? Well, we talked about inequalities the first time. What do we do now? Anybody. If you say divide by a negative number, I'm asking you to leave. I told y'all, no, that's wrong. It's been wrong in high school. It's been wrong in middle school. It's wrong forever. Never divide by a negative number. Never. Get rid of the negative first. How? Change the signs, change the inequality, change the sign. Change the sign, change the inequality, change the sign. You will make far fewer mistakes if you do it this way. So we have 2x. This one from less than becomes greater than. From negative 6 becomes positive 6. Negative 2x becomes positive 2x. Less than becomes, greater than becomes less than, and becomes positive 4. Whenever you change the sign of x, you change everything across the equation. To remind you why, go back and watch the videos from section 1.6, inequalities. Now I get my x by itself. Now, since the only thing in front of the x is a 2, I divide everybody by 2. Six divided by 2 is 3. X is less than 4 divided by 2 is 4. So because these are out of sequence, x is going to be less than or equal to 2, or x is going to be greater than equal to 3. That's what it looks like. That's your answer. Again, this is it. Had you most of this class, had you finished chapter 1 already, you would have done these examples in chapter 1, section 6. This wouldn't be the first time you see it. Absolute value of 5 minus 2x is greater than equal to 1. Is the absolute value isolated? Is it by itself? Yes. So now, if we drop them, what happens? Well, we look at our rules. We have this rule. Here's a. X is greater than a, so it's going towards infinity, which means down here, it's going to negative infinity. So it's x is less than negative a, or x is greater than positive a. We do the same thing with this. This is my a. This is my absolute value of x. The x is what's inside there. So the x is 5 minus 2x is less than or equal to negative 1, or 5 minus 2x is greater than or equal to positive 1. That's how you interpret these things. All it is plug and play. Once you get the formula down, it's just plug and play. Subtract 5. It looks like it. Is it? Oh, it is. Okay. And you guys still got it wrong. And we just did it. That's not good. So we have negative 2x is less than negative 6, or negative 2x is greater than negative 4. Change the signs, inequalities. Yeah, so you can follow the rest. So there's the end of section, end of chapter. That's the end of chapter 3.